One of the first things that was set for me was to put a texture on a sphere and then maybe show it. What we can see here is Blender itself. I've got a UV map and an image of the world that I've taken, and what I've done is I'm using this as my model in Unity itself. And if I have a look at Unity, we'll have a look at the demo I've created. We have a few different objects. We have the Earth itself that you can see here. We have the game, which is just here. That's what it's going to look like. We have the main camera looking at the Earth. We have a directional light, which I'm going to programmatically change to point from the camera itself. We have a star field that I'm going to generate. So instead of doing a skybox, you'll see some stars that I've generated. And we'll also have a pointer, which at the moment none of this is seen because it's all done programmatically. And what this will do is to be able to show us where point to the Earth from wherever we're looking. So if we imagine what this would look like in a VR world, it would be some sort of indicator to show you where to look. This is just a visualization. So if I run this, what we'll see is it will go through my code, and I've created 10,000 stars. And if I press to the left and right, you can see it changing in the background. The stars are staying where they are. I'm rotating the Earth and the stars just to make life a lot simpler for myself. And you can see that the thing I've got selected at the moment, the pointer, this is staying where it is. So as I'm rotating the Earth, the camera stays exactly where it is. Then I've added a couple of other things. So if I'm pressing J at the moment, I've just hooked it up to the keyboard. You can see I'm just rotating the camera at this point. Earth is obviously staying where it is. And I'm just doing a couple of different experiments here. If I press K, it snaps back to the Earth. You can see me zoom in and out. And if I press V, you can see the pointer I've created. So in the VR world, it's sometimes hard to work out where you are, but I was just doing an experiment here to see what this looks like. And we've got a few different types of objects. We obviously have the textured Earth on there, and we have associated with this this pointer, we have a line renderer, and we have these 10,000 stars and a directional light so we can see everything here. And we can also do some logging, which I've disabled at the moment. And if I stop that, that's what the demo looks like right now. And if I look at the code that I've written, we have a few different things, and it works via reflection, which is quite good. So if I double click on something and have a look at the project side, I'm able to look at the different objects. So C# files, what we've got here, and any helpers. At the moment I haven't done a game class or anything like that, so there's some abstraction I could do for these sorts of things. There is the different types of textures and also materials and meshes. So scenes have all the items within there, the types of objects, and we also have a shader that I haven't written, but I've just reused the code for the pointer object. So that's it from that demo. But if we look at the code, I have some helper logic. These could be replaced by singletons or whatever we needed. And what this does, this move pointer in front of camera, gets the camera position and where the Earth is, and gets the camera position, finds the rotation, and then it just puts this pointer in front of the camera at all times, but I could shift it to the left if I wanted to as well, so it doesn't block the view. And also the light as well, so the light is always pointing where the camera is as well. If I have a look at the initialization, this was me experimenting with the preload function. It's almost like a main function of C, where it gets called first, so you do all your setting up, etc. And if I wanted to do a game class or something, it would go somewhere like this. Then I have my pointer function. This is where I am getting the renderer. This is a drawing, and the line renderer that's attached to this object. So all the logic's associated, the script is associated with the object, which was that blue circle that you saw, and this rendering line is drawing from 2 points and finding a shader. If you had a custom shader, you'd put that in there, and then every time it calls update, it wants to always look at the camera. The pointer is always looking at the earth, and then I am drawing a line from 2 positions. This debug information is available within the inspector at all times, which is good. The rotation of earth, at the moment I have literally just doing it on a class by class basis, but I would have that as a managed section. And as part of this, I am working out from the camera to the earth and normalizing and point in its general direction. And then from there, what I'm doing is I am deciding how to do the rotation, so I'm only doing it on the y-axis, left and right. So zoom in and out based on the vector of the camera. This is what we calculated earlier in world space. Then we have rotate left and right, which you saw in the demo. And then we've got snapping back to the earth itself, and then we have the toggling something on and off to make it appear. So I am making that blue sphere appear, and what's attached to the sphere is a line renderer, the idea of components, and every time the screen is updated, move to cameras. So we've got something good here. And the other thing that we've got, which is quite interesting, is create stars. We've got 2 types of method here. One is around start, so we've got a wake, start and update to use. So start is when the scene is started, so in this case I'm creating all the stars, creating 10,000 of them in random space, and then I'm creating spheres at different sizes and scaling them associated with this. Then I'm putting them in this random space. At the moment I am not trimming off items that are between the planet Earth and the camera, because there shouldn't be really, because it gets in the way. And from here I've just copied one of the shaders and just applying it to there. And then on the update, what I'm doing is I am iterating through all the different stars, and I am rotating it around where the Earth is, which is 0, and then by changing this number, which would be centralized or whatever, would be the speed at which it rotates over time. So that's the star side. This is what a render looks like. So we've got the color, main texture, glossiness. So this is the allowed values. This is the range of allowed values, and this is the actual value. Metallic range, and you would have the other properties. And then we have some other types of surface shader, which I haven't really looked at that much really this time. But I know that fallback diffuse is when it cannot calculate that. It's got an alternative. The next thing that was very interesting to me so far is when you are developing a game engine and you're doing it from scratch, normally you have to write some sort of utility function, or you will do something programmatically that would take a long time if you were doing it manually. So if you've got control of the Unity world, for example, we have these two things I've added on to the editor itself. So Unity itself, we have this idea where find missing scripts recursively, and this uses standard C# reflection. And what this does is you create one of these items under the editor folder that you can see here. So there are two projects that we care about, and I haven't looked into the Unity side yet. And on here we can see we have an editor window, where it is, what menu it's under, and then what controls are added, and then when you click that button, where it is listed, what it will do, and then you can do things. So this type of functionality could be good for generating things via code without having to, let's say, my 10,000 stars, I would be able to put them and run that code within the editor itself rather than do it on Start itself, so I could generate it. I don't know if there's going to be any performance improvement for that. So I clicked find missing scripts, and this is what logic it has. And if you look on the bottom left here, it runs that logic. So it takes the assembly, it compiles it via reflection, and then from there you saw the debug log that gives us the information that we needed. So these are, you can extend the editor in lots of different ways, which would be good of getting information from let's say an external environment somehow, and maybe populating your scene somehow. So that could be a good alternative. Another thing that was very useful when you're exporting from Blender or 3D Studio Max, that we have right and left-handed systems, and what they need to do so they can be rotated properly. When they first appear in Unity, they are facing the wrong way, but it's possible to have these post-processors which will take the whatever was dragged into the asset manager, which could be models or textures or whatever the case, and in this case it is checking the file type, but if it's a Blender file then it's going to rotate it. So what this hopefully allows to do is you create something in the right kind of orientation within Blender itself. So if I switch over to a different view, it's a bit sensitive at the moment. So here we have my sphere and the modifiers that we've got on there to get it where it needs to be. And then from here, as this is, you can't see it in this example, if it's facing the right direction, when you export it, you will then go to Unity, and when you have added this file on here, what will happen is it will apply that code and it will rotate the model pointing to the correct direction, so then you won't have to rotate it every time that you export, which would be a real pain. And what's also very interesting is on some of these objects you can actually right click and you can re-import them to get the latest, or make changes and the change will also happen. So this flexibility is really good in terms of what you can do to create editors or interface with Unity from the outside world. So that's the demo so far. And what I've also done is I have set up Unity and actually exported a scene. So if I do build settings, we look that Oculus Quest has a certain type of texture compression, ASTC. Also scripts, debugging scripts on build, these are not ticked. And once you've connected and enabled Oculus Quest, which is done via the app, you are then able to deploy to it by build and run. But before you do that, you have to go into the build settings. So we can have version numbers, product name, and we can look at various other things. The previous way of doing things within Unity XR settings was depreciated, and instead what's happened is we now have these plugin providers initializing XR. So that was augmented reality or virtual reality, and then we tick